Today I am going to be demonstrating how to create an FE model of a femur and its implant using TSV Pre software. Here we already have the models of the implant and the femur. So the next step is to translate the implant such that it is fitted into the femur. Hence, select transform body, select translation, set the value of X as 100 and Y as 35. Select the implant body and click apply. By changing the transparency of the femur, you can see that the body has been implanted inside the femur. The next step here is to perform a body cut so as to remove the femoral head. Therefore, go to body cut, select on 3 points, and now mark 3 points along the neck of the femoral implant. I have marked 2 points on the same side. Now I need to flip the body in order to mark the third point on the other side. Select the femoral body and click apply. And hence the femoral head has been separated from the rest of the femur. Now we need to delete the femoral head. And hence you have your implant assembly ready. The next step is to remesh the body. So go to meshing, select local remesh, select the mesh type as try remesh, and change the parameters of the mesh according to your preference. Make sure that both the mesh and the implant have the same try remesh size. You can only select one body at once, so please complete the remeshing individually. Now that one body has been remeshed, remesh the next body. As you can see, both the bodies have been remeshed. The next step is to create a cavity in the femur where the implant is fitted. Hence, select Boolean minus, select the femur first and then the implant, and then click apply. Boolean minus has been completed. As you can see, there is a cavity inside the femur where the implant fits. Cut the body from the first model and then paste it in the second model. Hence the implant is fitted into the femur. The implant body needs to be remeshed again. Now that the body has been remeshed, the next step is face mating. Go to Assemble, Mating Face, select both the bodies and set the tolerance as 1. Click Apply. The operation has been completed successfully. Once face mating has been completed, the next step is imprinting. So under Groups, select the body under Mating Face, select Imprinting and then click Apply. Under Parts, as you can see, a new assembled model has been generated. This model needs to be cleaned. Therefore, it's checked for free edges and intersections, much like the previous tutorial. Since intersections are present, cleanup is applied. Intersection cleanup has been completed successfully. Thus now the model is ready. The next step is solid meshing. That is, the surface model needs to be converted into a solid body. Under solid meshing, select type as TET4 and click apply. Since solid meshing has been completed, the next step is to assign forces and constraints. Under LBC, select structural, select fixed constraint and select nodes on the lower end of the femur. Click apply, and hence a fixed constraint is applied at the lower end of the femur. Next, we need to apply a vertical force at the head of the implant. Therefore, select force, change the magnitude of the force. Under Z direction, select the top nodes of the femoral implant and click apply. And hence a vertical force has been applied. The next step is to assign properties to both the bone and the metal implant. Under properties, under the material library, as you can see, the parameters of bone and stainless steel are already present, and hence under property we select the material as either stainless steel or bone and assign the properties to the respective body respectively. The properties of stainless steel and bone can be viewed here. Similarly, the properties of the bone which has been entered can be viewed here. And hence, after selecting the body, the material properties can be applied to the respective body. Now that the material properties have been assigned, the next step is to generate a file for analysis. For that, go to analysis, select dynamis, create a new job and click apply. The file will be generated. After running the file through Dynamis, a .op2 file was created. Now this .op2 file needs to be imported in TSV Post software. The results of the analysis can thus be viewed. This describes the maximum von Mises stress experienced by the implant and the femur. Similarly, different other parameters can provide you with the results such as displacement, maximum stress, etc. Thank you for watching.